Boom! Alright folks, so we're continuing in our series of videos where we're looking at matrices. So in this video we want to talk about the addition of matrices and the subtraction of matrices. Alright, those two operations are pretty similar. One is simply the opposite of the other, and the rules and procedures that govern these two operations are pretty much the same. What rules and procedures are we talking about? The most important thing where the addition and subtraction of matrices are concerned is that the matrices that you're adding and subtraction must, M-U-S-T, capital, bold, underline, italics, everything, they must be the same. So in other words, the order of the matrices that you're planning to add together must be the same, identical. So you could add a 2 by 2 matrix to another 2 by 2 matrix. You could subtract a 2 by 2 matrix from another 2 by 2 matrix. You could add a 1 by 3 matrix to another 1 by 3 matrix. You could subtract a 1 by 3 matrix from another 1 by 3 matrix, etc., etc. So in the same way that when you're doing your regular polynomials, you cannot add a term in x squared to a term in x cubed to a term in x to the power of 4 to a term in x, etc. Alright, it's the same way with matrices. When you're adding and subtracting, the matrices must be of the same order. So, for example, with your regular polynomials, some people do this. They will see 3x squared plus 4x, and they will either put equal 7x squared, or they'll put equal 7x. No. You cannot do that. 3x squared plus 4x is simply 3x squared plus 4x. 3x squared plus 4x squared. Oh yeah. That will give you 7x squared. By the same token, 3x plus 4x will give you 7x. So, to add polynomial terms, the power of the variable must be the same. Alright? So we have a linear plus a linear to give you another linear. A quadratic plus another quadratic to give you another quadratic. You cannot add a quadratic and a linear to get some singular term. This expression will be just as there's nothing further that you could do to that in terms of addition. Alright? And the same principle will go for subtraction. So just as we have this principle in the addition and in the subtraction of polynomials, the principle is the same where matrices are concerned. So for example, you can add, let me start with some small orders. You could add a 2 by 1 and a 2 by 1. Alright? You could say 2, 1 plus 4, 7. Alright, put the plus sign back in the middle. You could add 85, 21, and 10, 19. You could add those two matrices. Alright, let me try a different order now. Let me say a 2 by 3, 2 rows by 3 columns. How about 0, 3, 14, minus 9, 6, minus 7, 2 rows by 3 columns. Okay, we're running out of space there. Alright, so we will skip that for the time being. Alright, so even on the big board we're running out of space, so look at that. Alright, so let me start with our small friends across here. You could add these two and you could add these two. What you cannot do is this. You cannot say 2, 1 plus 3, 0, 9. Alright? You can't do that. How you can do that? You cannot say 85, 21 plus 14, 0. You can't do that either. So for addition purposes, the rank, the order, the dimension of the two matrices must be the same. And of course, just as is the case with the polynomial addition, you could add more than 2 terms. So I could have 2, 1 plus 4, 7 plus 3, 25. I could do that. And I could add as long as I want to add. I could do the same thing here. We miss out the addition sign here. All right? And anything that we do with respect to addition, the concept is the same for subtraction. Now, how do we add matrices? How do we subtract matrices? What we do, we simply add the corresponding terms if we add in the matrix, or we subtract the corresponding terms if we subtract in the matrix. So, let me go back to our good friend. We go back to 2, where we were just now. All right? We can add these 2 matrices, and if we do that, the answer will simply be, switch up the colors now. 2 plus 4 is still 6, and 1 plus 7 is still 8. The answer is 6, 8. Make a proper 8. All right? And if we add these 2 matrices, the answer will be 95 on top, 21 and 19 is 40 below. All right? That is as simple and as straightforward as the addition of matrices is. So you would find that this video wouldn't really be too long, because addition of matrices and subtraction of matrices is just that. The addition, the simple addition or subtraction of each corresponding element. Yeah? All right. So that is what we have in red if we add in. So what about if we do the same thing? Let me subtract instead of add now, and we're going to use the same pair of matrices, the same pair of pairs, right? I have to get the English correct. So we switch in the sign now. So instead of addition, we're going to subtract. Yeah? And of course, if we switch in the sign, we want to change the color up for a little contrast too, right? So we switch from red and we go in orange. So if we subtract, boom, boom. Again, same idea. The order, the rank, the dimension of the matrix, of each matrix where you're trying to apply the operation must be the same. So 2 minus 4 is still, after all these years, in spite of COVID and the recession, 2 minus 4 is still minus 2, and 1 minus 7 is still minus 6. 85 minus 10 is 75. 21 minus 19 is 2. End of discussion. No set a long talk, you know. No set a long talk. So, with the matrices, when we add in and subtract in, just as with the polynomials, the order must be the same, the rank must be the same, the dimension must be the same. Yes, I'm repeating these words because I want these words to sink into your subconscious. You must be so familiar with the vocabulary that it doesn't matter which word they use. It doesn't matter how they come. You must know exactly what they're talking about. So you're not going to go into our exam and you see they talk about the rank of a matrix and you don't know what the rank is because you do all your past papers where they talk about the order of the matrix. No, 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 no. We're better than that. Yeah? Is there anything else that I need to say concerning the addition and the subtraction of matrices? All right. So let us now generalize. Let us make the thing more abstract. So having gone through the basic concept with regular numbers that we're familiar with, we could now make the thing more abstract. Meaning, we now have unknown quantities. And you know in maths, when we have unknown quantities, we represent that with letters. So for example, you might get a situation where they tell you, let me use 2 by 2 matrices, right? They might say, for example, 16 minus 7, 8, y. So I have one unknown there, plus 45 p. Let me see, boy. How are we doing this now? That plus that's supposed to be equal to something, right? So we could give a number here, we could get a value here. We call this x. 7. We call this 13. Let me see what's going on here now. So you're getting a little insight into the process of creating a question. All right. Let us say we have x, we have y, we have p, well then we had to have q, a. You know if so? 8 plus q is equal to minus 19. And let us see, we have p, we have, that means that we had to have a number. But if we have a number there, we want to have an unknown here. Y plus something, let me say 13. All right. And we have a number here too now. Y plus 13 is equal to minus 46. Totally random numbers, all right? So if some of the numbers end up being kind of crazy, that is the price we pay for being fully extemporaneous. Yeah? All right. So, you might get a question that looks something like this, and I am pretty sure that in your past papers, whether they be CSEC past papers, or Cambridge past papers, or any other past papers, you know, you could go on the internet and get past papers from a wide range of examining bodies now. Right? It's not like back in the 90s when I was doing CXC, where you had a kind of network among your people to get past papers, and in the case where you want to go outside, you had to write a letter and then wait and all of that. Technology nice now, make use of the thing now, right? So, if they tell us that this plus this is equal to that, we know that the process of adding matrices means that you just add the corresponding elements. So you might get something like this, and then they tell you, find the missing values, p, q, y, x. Yeah? So if we have to do that, it will proceed as follows. 16 plus 45 is equal to what? X. Alright? So 16 plus 45 is equal to x. 16 plus 45 is equal to 61. So therefore x is equal to 61. Alright? Equation 2. We want to find p. Minus 7 plus p is equal to 13. Minus 7 plus p is equal to 13. So p is equal to 13 plus 7 is equal to 20. 3. We want to find, well, let me go in order, right? 8 plus q is equal to minus 19. 8 plus q is equal to minus 19. So q is equal to minus 19 minus 8 equal to minus 27. And then number 4, we have y plus 13 is equal to minus 46. Y plus 13 is equal to minus 46. So y is equal to minus 46. Try to make it think properly now. Right? Y is equal to minus 46 minus 13, which is equal to minus 59. I don't know why I was thinking 57. Y is equal to minus 59. Alright? So, this is a simple example of the kind of situation that you could find yourself in where the addition of matrices is concerned. And of course, we could do the same thing with subtraction. So, just for the sake of argument, we're going to just change the sign, and of course, if we change the sign here, the initial equation, the sign will also change, and naturally, the value would also change. So, let me change this from plus to minus. Yeah? Change from plus to minus. Alright? And of course, the principle is the same. We minus in the corresponding elements. So in this case, where we had 16 plus 45 before, we now have 16 minus 45 equal x. So x will be 16 minus 45 is equal to what? Minus 45 minus 16 is 29, so x will be minus 29. All right? Notice how we're applying the logic. All right? Don't try this in your head in an exam if you know that you need to use a calculator. The exam is not the place to show off. Right? Same here. Number 2. Minus 7 minus p is equal to 13. So instead of plus, we now have minus. Now, the thing gets a little different now, because in this case, you're bringing over the minus p to be plus p, and you're taking the 13 across here. So, you see how the arithmetic changed with just a simple change in sign? So, p, you bring the p across here and I carry 13 across there. Minus 7 minus 13. So, p is equal to minus 20. All right. Before it was minus 7 plus p. In that case, the p will okay. I'm just making sure the arithmetic is correct. Similarly, for number 3, same argument. Instead of 8 plus q, we now have 8 minus q. So 8 minus q is equal to minus 19. So again, be in a similar situation to what we had across there. So in that case, we take the minus q and we bring it across here. So q is equal to, we take the minus 19 and we bring it across here. 8 plus 19. So q is equal to 27. And likewise, in equation 4, your y minus 13 is equal to minus 46. So your y will just be minus 46 plus 13, which would be minus 33. Cool? So, equal sign minus 33. Nice. So, quick example. These are the kind of questions you have to be prepared to do in a CSEC. You might get something like this as a number 10A in a CSEC for what? 2 marks, 3 marks maximum. All right? If you're adding or subtracting matrices, that is too straightforward and too simple to lose marks unnecessarily. All right? Once you understand the concept, the only thing you have to do after that is to simply be careful with your arithmetic, especially where the negative sign enters the picture. Because think about it. You really expect that you'll go in an exam and get matrices without a negative sign somewhere in there? No. You must get 1 or maybe 2 negative signs at least, minimum. So you have to be totally comfortable with addition and subtraction using negative quantities. So if that is something that you need to revise, then take this opportunity to remind yourself, and then you have to now go forward and do the necessary work. Sometimes you have to go back to go forward, to come back and go forward. So don't be intimidated if in the course of me working through this, you realize that your subtraction and your addition using negative numbers is a problem. No. If you had to do extra work, you had to do extra work. Simple and straightforward. As we say all the time, you just got to do what you got to do. All right. So one more thing before we close off this particular video. All right. The concept of what we refer to as equivalent matrices, where 2 matrices are the same. 2 matrices are the same if, well, the rank have to be the same to begin with. Right? 2 matrices can't be the same if the rank of the 2 matrices are different. So, if you have 2 matrices where the rank is the same, again, in a situation where we have a kind of generic expression, if they specifically tell us that the matrices are equivalent, in other words, that the matrices are equal to each other, then that could lead to another type of matrix question. So, for example, if they say that, let me see, 16x minus y, 49, 0 Z. If they say that is equal to the matrix, let us say, let me say, 2 plus y. You could get something like that. Right? 14. Let me say q. No, let me make that. We have x, we have y, we have q. Let me have to look for a p somewhere in there, right? Look, we have a z here, man. Let me change this to a p. Make life simple. We don't want to use too much as a p. Hold on. Make that into a p. All right? Let us say x minus 14. No. You want to put x minus 14 here. This, that. Let us see. Bim bam. Hold on. Let me leave the 0 here, just for the sake of argument. And let us put here 13. I put minus 13. All right, so again, we're composing our question on the fly, right? Spontaneous, extemporaneous, if you could use the language of the Calypsonian. So you might get a situation like this, where you have clearly a situation where the two matrices are of equal rank. 1, 2, 3, 3 rows by 1, 2, 2 columns. 1, 2, 3, 3 rows, 1, 2, 2 columns. All right? And just to mention, which I may have neglected in the very first video, when you're labeling the rows, we always start from the top and we go down, which you may have noticed, but maybe it didn't register. So I'm making sure to mention it explicitly here. Row 1, row 2, row 3. And with the columns, we start from the left and we go to the right. Column 1, column 2, etc., etc., etc. So suppose we have a situation like this, where we have two equivalent matrices, and we have some unknowns sprinkled inside there, and we need to find the values of these unknowns. So again, all you need to do is equate the corresponding elements. So we know, for example, that 16 is equal to x minus 14. So x is equal to 16 plus 14 equal 30. So x equal 30, we have that down. And if x is equal to 30, right, so this here will be 16, this here will be 30. If x is equal to 30, then, Papa, yo, look trouble. You see the kind of stress you could get through when you try to compose questions on the fly. We need to take that out of there. 30 will be equal to 2 plus y. So I could use that to find 30. And when I find y, I could put y here. Right. Just to make the thing consistent. All right. There, minus y. Let me leave that there. No, we can say p is equal to minus y. Right. And if p is equal to minus y, then we could just put some values on this in the bottom here. 17 and 17. All right? So in other words, for all practical intents and purposes, we don't even need the bottom row, but again, sometimes when I make up questions spontaneously, which is something that I like to do, you run the risk of making a little error here or there. So I'll leave in all of this in the video just to keep the thing dynamic, just to show you the interaction with the maths. You now have to understand that when you go into an exam, whoever sat in the paper would have already gone through all of this. All you have to do is just work and follow through. So having gotten x equal to 30, we know that x is equal to 2 plus y. So x is equal to 2 plus y. So 30 is equal to 2 plus y. So y is equal to 30 minus 2. Y is equal to 28. All right? So if y is equal to 28, right, so y is equal to 28. So this is 30 here. So this here would be minus 28. And if p is equal to minus y, p is equal to minus y, then p is equal to minus, remember, right, p is equal to minus 28. All right? So this here will be minus 28. All right? And then we just have here q is equal to 49. All right? So I could have worked this whole question as a 2 by 2 matrices. So you have that there. So what I could do is this. I could just do that. You have 2 by 2 matrices, and they give you all the different variables inside, and they ask you to compute the values of the respective unknowns. All right? And that is the question there. All right? So that more or less is it, where we come to talk about addition and subtraction of matrices. Your duty now is to find questions, preferably of an exam level of difficulty, right? The examination board doesn't really matter. Just find questions and practice. That is your duty now. So I want to take the opportunity once again to encourage you all to practice, practice, practice. Don't take it for granted that just because you understand a particular video, whether it's my video or somebody else's video, just because you understand the explanation that your friend or somebody else give you, just because you sit down in a class and you understand what the teacher do, that would necessarily transfer into performance under the pressure of an exam. You still have to prepare, and you still have to prepare by doing questions. All right? So, as always, keep good, take care, and looking out for the next video in this series.